given that you're 100,000 ahead of the globe because the globe can't get off of zero. That's the problem.
All right, cool. Now we're live, ready to go. So, start sharing. So, thanks everyone for coming to this. This is going to be fun, I think. Format is going to be chill. I'm just going to go through it, and you guys have questions, you can shout them out. If I happen to steamroll you, appreciate that for what it is, and we'll just keep going. But mostly I'll try to answer them as we're throwing them out. Globers, not so much. I already did one for you guys, right? You're naysaying, with the exception of Demon Stride, probably. Any flat earthers, though, ask for questions. Right, so this is going to be mostly about the counter rotation in the south, the fact that it exists, it's real, and how it works. And that's the entire basis of the presentation. So that's the only concept that we're going to try and convey to all flat earthers and viewers alike, right? So we're going to start with the visual star trails of both sections, so you can see that they're real and that how different they look. All right, so is everyone tuned in? We good?
Yes, sir.
All right.
Photographed at the O's sky.
Right, so this is kind of like what I would see almost. Something to be aware of, right, as I was saying before, the vast majority of the world's population sees the northern star trails because they live in the north. The northern hemisphere is like 88% of the population. 12%-ish, roughly, is the only part that ever sees the southern rotation. So when you're looking like for lack of evidence, it's just that a greater proportion of the people always have access to the north. So it's rarer, but it's definitely real, in my opinion. This video is cool because it goes from like the north to the equatorial view to the south, which is important when we're trying to figure out why it looks like that.
Concave?
So they call it the circumpolar star, right? But this is just in the south, looking south. This is what you'd see from, I think, near Australia. All right, so rotation point visible. It's definitely a focal point, right? You can see it's rotating around something near the middle of the screen. Yeah, so this is north, right? This is probably somewhere near me in the northeast of America, I think, judging from the sky. Because this is what I would see. North Star not necessarily directly above you, but between halfway and 45 degrees-ish. We are going to be playing with Stellarium a little bit too, but like this is exactly what Stellarium shows you. I think it mimics it nicely. I think there are problems with Stellarium, but for the most part, I would say it's accurate. Sorry.
Did you want to give us the globe reason why this happens?
Because the Earth spins.
But it would be a different direction the stars are moving, right?
Yeah, I'll get to that in a little bit towards the end of like what their explanation is. We'll use a specific example of the Southern Cross and kind of compare it. So yeah, like their answer for this is like, oh, just the Earth spins, but it's weird that they have star trails from like the space station apparently, which is not spinning, and they seem to have no problem with that. Weird. Right, so this is another usual time lapse, off-centered. If you play around in Stellarium, you can see exactly where you would see something like this.
So in the north, the stars are completing their circuit in roughly 24 hours. It's a little bit plus, I think. Is it the same with the south?
Yeah, 15 degrees per hour. That's the general accepted average
Hi.
speed.
Sidereal time.
Oh, concave made it. We were worried. So here's a good one. Here's like the equatorial time lapse where you get sort of off center pulls, and we'll look into this one a little bit later. Like where you see half of the pull to the left, but off screen can't really see it, and half off to the right. So the result is like this semi-straight star trail like that, right? So I mean, like the ball explanation is this is at the equator, right? And they see both poles, but it makes no sense later when you try to get the unique observations from different observation points, especially in the south. North again. It does seem to be that like the north are concentric circles and brighter and more compact than the southern counterpart. But that's not for this presentation. That's just an observation. I think it's interesting. Have you guys heard flat earthers like deny that there is a southern rotation at all?
Not a deny the southern rotation in general, but from different points, like South Africa versus Australia. It's supposedly seen differently.
Right. Well, that makes sense from a different observation. But I mean, there is no actual like south physical pole. Yeah, let's go back to this. All right. So that's pretty much the stars we're going to be looking at. But to understand why you see the counter rotation, right, you have to understand the sun. The sun is the best analogous concept for what we see on human perspective on a grand scale, right? So the anticrepuscular rays is clutch. This is a minute-long snippet I grabbed from a weather channel when someone called in about the crazy sun rays that they saw. So I'll just let this play.
Weather has been weirdly warm, but what happened Sunday evening seemed to defy logic. One glance at this picture and it would appear the sun was positioned below the northeast horizon. Light seems to be emanating from behind the mountains, but it was late afternoon, and the last time I checked, the sun sets in the west. Indeed, the sun was setting low in the southwestern sky, but shadows and light from a mix of clouds and the sun made it appear like the sun was setting to the northeast. Crepuscular rays are beams of light that appear to converge on the sun. You've probably seen these beams of light before. But what happened Sunday evening was anti-crepuscular or anti-solar rays that converge in the opposite direction. And you must have your back to the sun or sunset point to see them. The low clouds in the foreground are lit up by the sun. Shadows behind these clouds extend out towards the horizon opposite of the sun.
Right.
Anti-crepuscular rays
I don't know how
are
he's pronouncing it,
meteorological
but
optical phenomena.
he's literally leading
They
Wikipedia
are
right now.
essentially parallel, but appear to converge towards the vanishing point due to visual illusion from linear perspective. Big Sky Country often
Yeah, he literally read the Wikipedia definition, which is anti-solar rays, meteorological optical phenomenon similar to crepuscular rays, but appear opposite the sun in the sky, essentially parallel to the globe model, right? But not to us. Appear to converge toward the anti-solar point, the vanishing point, due to the visual illusion from linear perspective. So literally, the concept we're pulling from this is that the sun rays wrap around you in a sphere. You see them on the horizon from where you see the sun, and you see the opposing counter set and form a counter convergence directly behind you. It's not visible all the time. The conditions have to be right, but the fact that
anti-rotation
that it does it at all is mysterious. So here's P Brain explaining the same thing.
Okay, and they converge on the opposite horizon to a point, much like when they come from the sun. They come and they diverge out, and then they converge. Here, as though they're coming from a sun on the other horizon. They look the same way that the crepuscular rays do. The crepuscular rays diverge out from the sun, and when you look to the opposite horizon, the anti-crepuscular rays appear to be diverging out from the sun on the other horizon.
Right.
But they're not. They're just the convergence of the crepuscular rays due to perspective. So
That's a crazy concept to get, but that shouldn't be a problem because that perfectly phenomenon exists as it's explained in the globe model. So everyone good so far.
Illusion, almost as if it's a mirror reflection of the crepuscular rays. So that's why they're called the anti-crepuscular rays.
right? So you see how there's a counter convergence point from behind the observer. The sun isn't there; it's on the opposing horizon. But the crepuscular rays go inverted and form a counter convergence point. This is kind of crucial because this is what I'm going to argue
But they're
exactly
not the
happens with the
source
sky
of
in
the
the
light
night.
to begin with. The
What
source
happens
of
with
the
the
light
stars?
is the sun. So that's the same way that the stars, the source of the rotation is the northern rotation, not the southern. The southern is just an anti or a perspective produced counter rotation.
P-Brain does a pretty
one.
P-Brain does a pretty good job explaining this.
Crepuscular
Like right
and
here.
anticrepuscular rays is some strong evidence that perspective will in fact explain that phenomenon. So that's why in fact I'm using the crepuscular and anticrepuscular rays to show a correlation between Polaris and its counterclockwise rotation.
So in this example, the stars literally circle over flat Earth with around Polaris in one circle, one concentric circle emanating outward from the source. That's all that there is above us. We see it in the south due to perspective, but there is only really one celestial pole.
And the clockwise rotation in the
Seem like how there's not two suns, right?
You might say, well, how's that? Okay, let's say the sun's overhead, right? And let's say you can see all of the rays. Let's
Now let's skip through this. Here we go.
They will diverge out from the sun, spread out overhead, and then
Right, so this example right here, this is kind of explaining it. If the sun was over there on the right, on the east horizon, like rising, and the observer's in the middle of the circle, then as the rays emanate outward from the sun, you'd expect to see them where it's circling now. You'd expect to see them continue past the observer, off into infinity, in the same pattern as they were, right? But that's not what they do. That's not what anticrepuscular rays are. They do something weird.
The ray is right here at the point of convergence for the anticrepuscular rays. Take a look at any one of these rays. They all go to the same place, you know. Any rays in your western hemisphere of celestial vision, this vision circle, they'll all converge at the same place, 6,000 miles away from the horizon, because the precedent is set with the anticrepuscular rays.
All right, sorry. There we go. So this is from that stereographic reality video, but the only part that's important here is how they track the sun, right? They literally draw an azimuthal grid around the observer and then track it in varying degrees of longitude and then track it how it rises. See how it's a perfect circle around the observer? This is what drives programs like SunCalc and how they get the sun shadows. Literally, it's by the observer all over the map. You see how it's working? And the sun declination changes south of the equator versus north of the equator. It's still tracked in a semicircle above the observer. I also should have said that all the sources for these videos are in the event description. I linked them up there, I think. Mostly everything I used for this. How are we doing so far? Anyone have any questions? Chilling?
Oh, I have many questions.
Earth is life. Chill out, man. We already did the global version.
A picture of anticrepuscular rays that I was able to take from inside of a plane. The sun was, I was like looking down at the ground. It's exactly what is being described here for the anticrepuscular rays. Let's see if I can find it.
Right, so it's a phenomenon that exists. People shouldn't be refuting that they're not real. They are exactly as they say they are, right? And they're simply a product of human perspective on a grand scale. The only other comparable grand scale, I would argue, of the sun would be the stars. That's why the same effect applies to specifically those two things in the celestial sky. I think Jeranism had a video called the Personal Atmospheric Dome, which is not a name that I like or familiar with, but the concepts he explained are pretty similar, pretty analogous. The atmospheric compression is densest at the horizon around you and least dense up top at your zenith, and that's why you get, you know, optical phenomenon like supermoon and crazy sunrise moons, and where it appears bigger on the horizon than it does above you. Right, so I mean, here's the concept from I think the video we've all seen, right? Like, actually, here, let's do this one first. Let's do a minute of Mitchell from Australia. Explain it in 1 minute.
In reality.
Oh my God, Shane. Mitchell from Australia, really?
we also have a flat sky plane above us where the celestial bodies exist. From the vantage point of our flat plane, when viewing the celestial bodies, we perceive their position and movement as a dome. This is purely our perception from this vantage point on our flat plane. It's not actually a dome above the Earth. All celestial bodies rise in the east, move in an apparent semicircular motion above the sky, and set in the west. Now don't get me wrong, our Earth is measurably observed.
This is just how vision works. It's how we see things. You see things that are really far away appear to set because you see in a dome, in a finite dome of vision around you. You can't see forever. So the same thing applies to the stars.
Above our heads, we can see that everything rises in the east, moves across the sky, and sets in the west. We just perceive a motion,
I'm gonna let
shape for that matter. But I digress. Looking at this flat,
it's not where the ground is, it's over the horizon.
There we go. So this is like an analogous concept here.
That's all the stars we can.
Right, so he gives some specific measurements here that I might not agree with. He's just giving roundabout approximation figures. I don't know if I agree with that at all, but he's saying that from the middle, right, from the middle of the flat Earth, you look up, you see the stars processing above you in an equatorial plane and eccentric circles from the middle, and you see a portion of them represented in a half sphere around you at vision, and that's what he's representing. And in fact, like, this video has been out, and other people have showed these clips to explain, to like try to explain what some of the stars were, and they put like 4 in the south, and it made zero sense to me. I had no idea what they were talking about. It was very confusing. So stars that are lower to the horizon appear at the edge, right? So they're a little bit further away. And this is specific to each observer. So you see how literally he went right now he's about halfway between the Tropic of Cancer and the North Pole. So he went at the North Pole when it was exactly at the zenith, right under Polaris, and he went about halfway degrees, so it's about 45 degrees if you were to draw the azimuthal grid around him. That's where you see Polaris. And that's where you'd see the rotation point in Stellarium and in real life, right around there, about 45 degrees. That's roughly what I would see, actually, right? Because he's roughly standing where I live.
Standing at the North Pole, right? And the stars rotate. You have Polaris overhead, and the stars are rotating around you counterclockwise. As you move south, Polaris starts to lower in the northern sky, and the stars start to tip. It's almost, I like to think of it as like a salad bowl, right? And so the salad bowl has the bottom is up.
Yeah, I'm not sure I like that analogy.
And the rim of the bowl is on the ground. That's also where the sun would go around from your perspective at the North Pole.
The salad bowl. I don't know if I like the salad bowl. The dome is sufficient. I mean, it's not a real dome.
I've used the bull analogy before. Here comes Tim. That says a lot.
So I mean, like, what I'm going to show now is we're going to jump into Stellarium a little bit.
So as you head south, the salad bowl starts to tip onto its side, and so that, let's say you travel 3,000 miles south of the North Pole, everything would be rising in the northeast, sweeping out over the southern sky, and setting in the northwest, like this, right? And if you go all the way to the equator, Polaris would now be sitting on your northern horizon. The salad bowl would be completely tipped on its side, and half of it would be below the horizon.
Exactly.
And now all the stars would be coming up east to west, and so the sun would also rise east to west. And now that's a hard one to visualize, because if the stars are all rotating like a big disk around Polaris in the sky, a big flat disk, or if they're not a disk, they're a big dome, whichever one they are, if that's the case, and if it's a big flat disk and it's just perspective that's bringing the stars down, well then the people in the south say, hey, well the stars should be rotating just above the horizon, right? And stay equal.
All right, so we're going to jump into Stellarium for a second, but this is we're going to describe what the azimuthal grid is, right? That's the little dome he just drew over the stars and paraded around the flat Earth. That's the same concept as the sun calc, the same concept as how you track sunrises and sunsets online, timeanddate.com. We're going to show you how it's used in Stellarium, but here's a little explanation video that I made with it. All right, cool thing about Stellarium is it has this feature called an azimuthal grid, right? As soon as you activate this, you can see exactly how Stellarium works. by plotting everything around you in this azimuthal dome in a grid format, you see? And then no matter where we go on the Earth, this grid comes with us, and it's how we are able to plot stars in the sky from any location on Earth. It's how stellarium works. See? So in the azimuthal grid, it'll always be a dome above the observer, so that it'll always converge at your zenith directly above you, and that's specific to the observer. And then you see, well, actually, here, let's go into actual stellarium. There we go. Everyone see me?
Yep.
All right, let's make it nighttime.
We see your stellarium.
Huh. Uh-oh, I made it infinite time. Dude, how did I make it infinite time?
Dude, I've made it do this before too. It's really annoying. It's like really easy to make it do this.
All right, well, screw you. Let's just
Shout out to Julian and Killian on the screen. I see that.
Holy shit! All right, I just wanted to make it nighttime. All right, so if we look, we have this azimuthal grid literally focused around the observer, and on the round you see you get elevation angles and measurements, 340 plus 330 in 10-degree arcs all the way around you. That's how you track elevation angles of celestial objects of a star. It's how celestial navigation works. Again, if this was at the daytime, this was how the sun would track an elevation angle relative to the observer, and it would literally match exactly. And when we get into Walter Bislands' model in a little bit, you'll see this is doing the exact same thing. There's a little circle above the observer, right? So this is, again, based on reality, what observation. They claim it's based on the globe model, ha ha ha, but really it's based on observable skies. So if we pick, let's say, a constellation, like you see this Delphinus constellation right here, we're going to pick that and we're going to move a little bit. You see how in the northeast it's changed elevation angle. We go a little bit further, it's changed elevation angle again. Now it's way up there. If we go a little bit further, it's still way up there. Like you see, literally, it's different to every observer. Now it's all the way over here, all the way to the right. See how we see it differently? We're all the way at the top of Russia looking at the same constellation, Delphinus, and it still appears way to the observer. And the more we track the way that works, so we can go south with it, so it appears up, right? Delphinus is over here, now it's above the observer. So using the azimuthal grid, you can track where these things are relative to the observer. Now, that's not to be confused with the equatorial grid. This is essentially the global positioning system, the coordinate system of the globe, longitude and latitude derived from the globe. This will always focus around Polaris, right? So this is always around Polaris. And if we go to the equator, as we were shown in the other video, it literally, Polaris goes a little bit lower, and then when you get to the actual equator, it's almost invisible. It's almost invisible. And then you get to see on the opposing side, the counter rotations start to pop up. But this is where we got to go to Walter Bislands' model for this to make sense. All right. So we have the same thing represented here, right? It's a nice tool, this Walter Bislands model. It's a manipulable, movable, sort of scalable personal representation of what we just looked at. The observer in the center is going to be you, and the same azimuthal grid around the observer represents the smaller dome. And I put the stars in a flat pattern above the observer because I think that's what they look like. And you can see as time progresses, literally, you see stars rotate above you that are mirrored in this personal grid around you, just like Stellarium, just like SunCalc, just like timeanddate.com. And for when we see, for the southern rotation, literally, as we get to the equator, so right here is what we're looking at. This is when you're at the equator, Polaris is still visible to the observer, dipped to almost 90 degrees, almost buried in the horizon. And remember when we started, this was the equatorial view of the video. right? It was going like this. So let's see if I can bring that up, actually. Huh. VLC, stop freaking out. No worries. We'll do a side by side and we'll show you what I mean. Oh man. VLC is creeping out. All right.
Kill it all, I guess, huh?
Yeah, it's got multiple instances now, you little bitch.
So somebody in the YouTube chat had a question. Plain truth. The thing I find very strange is, with all the high altitude balloon footage video I have watched, never have I seen the moon in one, only the sun. Plain truth then says, maybe there are videos with footage of the moon. Anyone else notice the same? Anyone with some input?
There's plenty of videos with the moon.
Yeah, man, it's something I look for a long time, actually. It seems like there is no over 80 to 100,000 feet. You can't see the stars, the sun, the moon, or maybe the sun, but the moon. I think you always see the sun.
Thanks for the comment. Appreciate it.
Screw you, VLC. VLC's being ridiculous. All right. Well, I was going to do a side by side, but I can't find it. It won't work. All right. So you guys still see the Walter Bislands model then?
Yeah.
All right. So the equatorial grid, the one that we showed right at the beginning, when the celestial equator, and you saw kind of straight lines as they both circled around both poles. You have to visualize it now, right? So like literally you see both poles from the observer, and you see the sort of straight appearance of the stars circling around you. And this is why we get Sigma Octantis, right? So if we go souther from here, you see it popping up over here. So that little red thing is what they refer to as Sigma Octantis, the southern pole star, the counter rotation. Notice that this is this model, right? It's a glober who built it based on observable reality, and he claims you need the globe model, but that's ridiculous, right? So as we go with this time lapse, we see the southern pole star, quote, visible as it circles around. The thing is, though, this is visible for every observer in the south. So literally, from this point, you can move this, and this goes anywhere around the flat Earth, sees the same counter rotation from the south, looking south. It's kind of wild, right? So looking the other way, it's counter rotation. Questions?
So are you?
All right.
So
go ahead.
How do you explain the fact that you see Sigma Octantis or the southern pole star facing south no matter which direction you go? Like when you moved the observer, observer longitude, the direction that you're seeing the southern pole star is, well, always facing towards the south, towards the exterior plane.
Yeah.
And so if you have two observers on the disk of the Earth, then they would both see the southern pole star in two separate directions if they're in different places on the Earth.
Yep. That's because the southern pole star isn't really there. It's the dimmest, fadiest. All it is a counter convergence point from human perspective, driven from these stars circling around you in perfect circles above you. But when you're so far away from the center, what you see is the anticrepuscular version of the stars and a counter convergence point on the opposing horizon. It's the same effect that you get from anticrepuscular rays. But that's why there's a counter rotation at all, and that's why it moves with the observer, and that's why they're all looking south, as apparently in different positions.
And so does Sigma Octantis actually exist, or is it just an optical illusion?
It's literally an optical illusion in my mind. Yes, sir.
Okay.
Can I ask that guy that's asking a question a question?
Get him, Timbo. No, he's one of our friendly gloopers.
Yeah, no, that's all right. Where on Earth do you see Sigma Octantis from the south at the same time?
We may be misunderstanding each other. What I meant is if we have the flat Earth like this, the disk of the Earth, and you have somebody say on where Shane currently has the observer, and then if you were to take observer longitude and move it someplace else, they would still anywhere else. Like Shane, if you could just move the thing for observer longitude for me. No, not latitude, longitude. Yeah, like right there.
Yeah.
See?
So it's night time at different times. So.
Yeah, it's not different times. They're just two people at the same location, but they would be facing separate directions to see effectively the same thing.
You don't see it in the same direction at the same time.
Well, they're both facing south, but that's only because on a flat Earth, south would be all outward directions.
Yeah, but I don't think you're understanding what I'm saying. If you're on the west coast of Australia and South Africa, and then a guy in South Africa, you won't be looking directly south from the compass to see Sigma Octantis. Anyway,
yeah, it's
so you can both see it. It's just different times of the night, and it's in a different position in the sky. So that's the only time you're going to see it at the same time. You're not going to see it in Australia and then see it in South America, are you? It's night at different times. So,
I see what you're saying, because one person would be in day and the other person in night. I wasn't really thinking about that.
That was my second example. Yeah. The first example was it's different times of the night.
Yeah.
So you're not. That actually Sigma Octantis doesn't stay in one spot. Yeah.
There we go. Timbo, our resident Australian observer. By the way, thanks for coming to this, Timbo. I could have invited you personally.
All right, so
glad you showed up.
I really like your version of this. I think it's great. I love it.
Nice. So there's a video I think that Flat Earth Banjo did. It's specifically on the Southern Cross, but I think it's pretty close to what Velkami's getting at here. It's so it takes one constellation, the Southern Cross, simultaneously visible across 3 points on the plane, right? And then they say, how is this possible on the plane? I think he does a pretty good job of explaining it, but I think because what I did was I added the azimuthal grid observation into this equation, and I think this is what we're gonna end it out with. So it only makes sense with this. But let's take a look, a couple of minutes at Banjo's video, and he'll explain the kind of the parameters. I did get VLC working again, because fuck you, VLC. How dare you?
Time. Now another thing that you must do, you have to go, let's say this website here. In this case, we're going to use the Mercator project. So I went to timeanddate.com, that you see a day and night world map. This is July 22nd, 2022. 4 p.m., 16 hours UTC time.
Right, so this is a pretty well-known example,
American
right?
Way of
and this is
the time.
a specific
1
observation.
1 p.m. in Brazil, 6 p.m. in South Africa, and midnight in Australia. So let's advance, go ahead and go start. Let's advance, increment 1 hour. So now we have 5 p.m., which is 7 p.m. in Africa, 2 p.m. in Brazil, 1 a.m. in Perth. Another hour, 6 p.m., 3 p.m. in Salvador, 8 p.m. in Africa, 2 a.m. in Perth. So now you have 7 p.m. UTC time, 4 p.m. Salvador, 9 p.m. in Africa, 3 a.m. in Perth. 8 p.m. UTC time, 5 p.m. Salvador, 10 p.m. in Africa, 4 a.m. in Perth. Now you have 9 p.m., 21 hours UTC time. That's 6 p.m. in Salvador, Brazil, 11 p.m. in Africa, 5 a.m. in Perth. Now we cannot increment 1 hour now. We need to increment only 40 minutes, and let's see what happens. Just 40 minutes. All right, at this point, a person is staying in Salvador, Brazil, anywhere in Africa, and Perth, Australia, they can all see the Southern Cross. Now, why do these people can't see the Southern Cross? Well, that region in Brazil, where Salvador is located, is the easternmost region in South America, which means closest to Africa. And the Southern Cross is above Africa. Someone in Salvador looking southeast, he or she will be able to see the Southern Cross. Now, it's very important that the person standing in that region looks southeast. You cannot look south like he was demonstrating. Lack of research, just laziness, or just, I don't know, he tried to deceive his viewers. Now let's move to
it's actually southwest, I think. I think he misspoke.
Why can you see the Southern Cross from Perth at that time of the year? Well, very simple. Perth is located in the westernmost region in Australia, which is closest to the African continent. That's why these three people in these three different locations will be able to see the Southern Cross. That's the best time. Now you have 23 hours UTC, 11 p.m. It's already 7 a.m. in Perth, midnight UTC time. That's 8 a.m. in Perth. So people in South America and in Africa can still see the Southern Cross, but the focus is on all three parts of the flat Earth. Now let's do it again one more time. This time, left 180 south. Let's increment
Come on, Banjo.
Only 40 minutes. There you have it. The Southern Cross right above Africa. Three people stayed in these three different parts of the flat Earth.
So remember this right here. This is the Mercator projection, so the globe map of how this is possible. But I'm gonna put it on an actual globe, and we're gonna look in Stellarium and get the bearing and look at the azimuthal grid elevation and see how this is actually possible while all observers actually look southwest. But here
Can see the Southern Cross.
The ghost in Pac-Man chasing Pac-Man.
The person in Salvador has to look southeast. The person in Perth, Australia, has to look towards the southwest, and that's how this person will be able to see. If you keep going, it's going to be daytime in Perth. Now, two people still can see, one in Africa,
so then I think he wraps it up,
Brazil,
and he puts it on the flat Earth map. So
it's pretty easy to do. We're going to run this one more time. The way we will do it, let's map his deceiving picture. So let's go ahead and start again. That's 4 p.m., 5 p.m. now, UTC time, 2 p.m. in Salvador. Now you can see now, once we convert the Mercator's projection into a flat Earth map, you can see how close that region of Brazil is of Africa, nowhere near what he had, a person in Patagonia, Argentina. So let's go on, increment another hour, 3 a.m. in Perth, 4 p.m. in Salvador, Brazil. Now 9 p.m. UTC time. Let's increment now only 40 minutes, and there you have it. Three people standing in this.
All right, so that's the concept, but those directions are wrong. That really isn't working. But so I took this image, right, and we moved it into other stuff, and I used the azimuthal grid over each observer and used the direction with the compass to make it work. So let's see. I'll switch sharing to an actual screen. There we go. So real quick, this is celestial navigation, the azimuthal grid around the observer. It's Polaris is at the zenith in this one, but that's not how it works. All right, this is literally how they keep track. And here's the actual observations of the Southern Cross at that time, at that UTC, from these observation points. So from Salvador, south, almost due south, southwest, right? Over here in Johannesburg, southwest, southwest, definitely. And over here, more south, but it's still on the horizon. This is in Perth. So when you think about it, on the bottom of a globe in all these positions, to look south and southwest to see the same constellation is kind of goofy here. I'll get that up. No, not that. Here it is, kind of drawn out, right? I think Bacon helped me with this modeling. So he did all south-southwest, but that doesn't really work because that's not what the observation matches the observation angle. So here it is. So I kind of modeled it out using the Walter Bislin model, matched the time and date, and then gave each observer an azimuthal grid, and then marked the direction in which they were looking. So you see up top, it's literally in the middle, and then emulating at the same time how each observer sees this from the azimuthal grid. Right, so it doesn't work on the globe because they're all looking southwest to see the same thing. However, if you use the azimuthal grid on the globe, then it does work, strangely enough, since this is, again, how Stellarium works, how SunCalc works, how timeanddate.com work. It's kind of haphazard, but if you see on the observer, if you put this grid, then they see it at the correct declination, south-southwest, and this guy sees it at the correct that declination, south-southwest, and this guy sees it almost south. You see? It only makes sense with this applied. What do you guys think?
It sounded like you said, though, the guy in Brazil has to look south and east, not south and west.
No, it's
like
not
the
east.
guy in Australia.
It's all variations of south-southwest. Some is more southward than southwest, but still southwest.
Yeah, I thought I heard him say, though, the person in Brazil would have to be looking southeast.
Yeah,
That's the way, like when he was doing it, it looked like he was pointing to the
Yeah, that's why I said he was kind of wrong. I said that like at the time. I said I think it's wrong. I think it's southwest because when I went to the actual time in the program, it was southwest. So I assume he made a bearing, and if not, then I disagree because it's south-southwest and all the bearings here. I think I have all the images still.
Hey Shane.
What's up?
Did you mess around with the magnetic declination as well?
No, not really.
Probably even get you closer.
But I think that same concept would apply to how you read declination in the sun, right? Because like I think it has a lot to do with how you observe the sun calculations too. Like so, I have a whole other built-up thing. Here, let's see.
Yeah, that's really interesting, man.
Because there's like
I was going to say the last guy who came on 24/7. I think Timbo was there. Bad boy, was it? He sounded like
he's a god.
Yeah. Well, he sounded like he got a French accent, and he brought this up. He was talking about this for like half an hour. So this is awesome, Shane.
Nice.
Shane, can you go back to the image that shows the globe and the 3 white arrows pointing out into space?
Yeah. Hold on. I wanted to find the sun example while I was on it though.
Oh, I'm sorry if I broke into somebody else.
Yeah, so here we go. Like so, same model, same principle. From this point, the sun would be all the way over here, but it appears to rise in the east over here. Here's a compass looking south from the observer. Here's the north. Right, so here's where it appears in the azimuthal grid around the observer, and then here's where it would set. Right, like so it sets south. What was it, like a little bit south of west? Right, so definitely correct in all the crazy. It's actually all the way over here, and it's continuing its perfect elliptical circuit, but it's so far away that it appears to set on the horizon, and it just goes into the declination of your 90 degrees, so you can't see it beyond the horizon. The same thing that happens to Polaris when you go past the equator. You're just too far away for it to see. And I think I have a GIF that made it. Yeah, let's see. All right, so yeah, it slows down. Literally, the sun passes over, you see it rise and set, rise and set.
Like, that's cool, man.
Now, what was I looking for? Oh, yeah.
Well, on this right here, I'm not understanding how this would prove flat Earth because
it doesn't.
To see the sun. Okay, so you're not using. All right, I gotcha. I was gonna say because that would be Bendy light.
Well, no. So here, let's go back to Bislands' model then, so we can crush that one. Bendy light, I love it.
Well,
You-
I mean,
you're just explaining like southern star rotations, aren't you?
Yeah.
Yeah,
How they could work. Yeah.
That's all.
Yeah,
we're
we
going
could
for.
ignore the sun thing and just concentrate on star trails.
Well,
Some things good. I really like that.
The azimuthal grid is kind of the explanation that solves them both, though, right? So, see, if we look at these dome rays, so Walter Bisland is famous for saying that this works by bending light in impossible ways. And what he's talking about, in my mind, is that because his model here connects these specific stars on this circular circle to the specific stars on the grid to show you that this star is setting at this declination when it's this far away, that the line he used to connect these two in observable reality is bending in an impossible way. And it's stupid because you don't need these ridiculous bendy light rays to demonstrate how something far away from you sets on your horizon with your azimuthal grid. It's not required, right? Again, it's how stellarium works. It's how sun calc works. It's how date and time works. It's not required. These little lines are a cop-out. Yeah, these are impossible bendy light rays, but they're superfluous and unnecessary.
We'll just go back a tick there, Shane. I think what he's saying is that so the star you've got there in the top right that's got the line diagonally down left across the screen, right? So I don't know, I could see a mouse before, but that top right star that's got the red line to it, yeah? So go back to where you had it before. Or even that one there. So stop there, go back. So just have a look at the star at the top. The very top.
Yeah, that's goofy. That's why I turned them off.
So, no, just freeze there. So I think what Walter Bisland's saying, right, is that very top star in the middle that's got the ray coming from it down into that dome type thing, right? I think he's saying that it's appearing to the observer like, look at how the light goes from that star to where it is in the sky to the observer.
Yeah, completely
right?
unnecessary. That's stupid though. That's a
Why is it
stupid way
stupid?
because that's not how you have to depict it. Things far away from you set on your horizon.
Where the star appears in the sky to the observer means that the light has to bend like that. Because in this model the star's actually over there, way over, not where it's appearing to be to the observer.
Are you late to the presentation?
So the same way that the sun rays, right, form anticrepuscular rays, they're not actually bent behind you. Your view, your perspective is doing that. So the same thing is happening to the stars. And that's the same thing that when they go so far away from you, they're actually setting. They may be further on their path, on their elliptical orbit, that you can't see them. So they appear lower on your horizon and very distant, right? How does that not make sense?
Well, this guy's looking southwest as far as I can tell, but the star's actually northeast, but it's appearing to be southwest.
Yeah, that's why I turn these dome rays off all the time, right? Because they're very, very stupid. And they're not necessary for the conceptual model to make sense. Yeah, great.
Well, but they are, because the star, when we look out, right, when we're on the ground and we look out at the stars, they
He
appear
just said
southwest,
why they're
but he's
not.
saying that they're northwest.
Sure. So then, do you think stellarium and sun calc have to use? Do you think they have to use the same stupid bendy light or what?
Yeah.
Right, which nobody can actually prove. Yeah, nice.
So do you think stellarium and sun calc use the same stupid bendy light rays that are impossible to program their functions or what?
No.
Very good. Right, because stellarium uses the same thing, as we pointed out, literally an azimuthal grid that makes the stars appear that way. Right? It's not crazy to say that you see in this little grid around you. It's how everything works, actually. Here, look at this.
You can actually identify the mathematical model that that Stellarium uses. They line it out on their website and give you the references. So if you want to go and look at the model they use, I actually did, and it's pretty beefy.
Beefy.
Yes.
Beefy.
But it does have an azimuthal grid around the observer to mark elevation angles to match the almanac at different observation points around the world. Or does it do something different?
The mathematic models they used to plot where solar system bodies specifically, because I was looking at it for eclipses and such, and the models they use for that. I'm sorry to say it is actually using a spherical model.
It's using the recorded observations of the sky model. That's like saying that the globe predicts eclipses, but remember, we went into the Metonic cycle and the 15-year solar cycle and the 19-year lunar cycle and the great astronomical year of 651 years. And if you memorize those patterns and you see the series and patterns and teams of eclipses that seem to unfold, then you can start making the same predictions as the ancients, right? So to say that that's globular based is disingenuous.
They're not actually using.
Yeah, I think on a mathematical model, you should be saying spherical math or spherical trig, or rather than spherical model, you should be specific. And I was wondering what beefy is a unit of measure for.
You see, so this is back to the globe trying to find the same observation that Banjo pointed out by observably looking southwest and seeing the same constellation. It's weird and wackadoo, man.
Yeah, why do you guys always say predictions when it's postdictions?
Very good point.
The sky does the same thing. It has been doing the same thing all the time. So people record it. So they're not predicting anything in the model. They happen, and they happen again, so people record it so they know when it's going to happen. That's how it works.
Well, I could go into the solar cycle stuff and current methods of predicting eclipses.
Yeah, it's a post-diction.
Hold on, that's off topic from what Shane is discussing.
Okay, well, you brought up predictions.
I was just saying that for Stellaris, I was looking at the math they use, and it's specific to eclipse predictions. That's the only reason I know you can find their references on their
They're not
webpage.
predictions. You've got to stop saying predictions. They're postdictions.
You know what I mean, so let's just stick with that. Anyway, Shane, I'm sorry, I didn't mean to interrupt.
That's cool, man. I'm glad you
just take the. It's okay.
So look, azimuthal grid, different from the equatorial grid. Again, same way. Like this would be the equatorial grid. This is how you could see where the actual rotation point should be, right? This is what we started with on the equatorial view to go back into Walter Bislands' model. So I was trying to show this with this. There we go. So if we show it on the equatorial view again, let's put it over here where we can see it. So literally like right here, this is what we're illustrating, right? This is the same thing. This is why I say you don't need stupid bendy light, because this little observation grid around the observer is literally mimicking what we're seeing over here to look at the counter convergence point. And in here we can look to the south and see the same thing, the same little budding sigma octants popping up the same way this guy can over here.
I think you do need bendy light to get the stars to appear in the right place on that dome.
No, I really know that hardcore globers have to stick to that, but it makes absolutely no sense and it's stupid.
Well, that's
you don't need.
That's what Bislands' model's saying.
Yeah, I know. He says that, right? Like I said that right when I started. That's what he says, right? That's what he says all the time. There's even a wonderful meme on Flat.ws quote debunking this by saying the same thing that he says, but as I pointed out, it's superfluous. It's absolutely unnecessary. It has no bearing on reality. And if this model uses the same faulty bendy light, then Stellarium has to use the same bendy light because the same azimuthal grid functionality is built in. Elevation angle from the observer. That's it. That's all it's about, man. I don't know why you're hurting so hard.
So,
I'm not hurting. I'm just saying it doesn't make sense.
Just to make sure I understand, you're saying that the stars are not actual physical objects, but a product of a crepuscular ray model, correct?
No, that's not at all what I'm saying. So I started by saying this whole presentation is just showing you the counter rotation, the southern celestial rotation that 12% of the world can observe, right? 12% of the population observes the southern celestial rotation. That's what this is about. The fact that a counter convergence point, meaning if the stars are literally in concentric circles above us, emanating from the center, like this model is showing, and the further south you go, you see the anticrepuscular version of the concentric star circles above you doing the same thing, east to west rotation. Because you're so far away from the source, you don't see the source from the equator. Like, see, this is looking north. You don't see Polaris anymore. You see the counter convergence point. They still appear to rotate. But if you look south, this little point moves with each observer, even in Stellarium. Even if we go in Stellarium and go around the world, see what I mean? All these people are seeing the southern rotation point. all across the world, the same spot, same declination.
Okay, so the stars exist except for Sigma Octantis because it's a product of the anticrepuscular rays producing the effect of star trails.
Oh man, that's so wrong. The only analogous concept is anticrepuscular rays appear in a counterconvergence. So they appear to converge behind the observer. They don't actually do that, right? You think that they go out and they could continue to emanate outward from the source all across but they don't actually do that. Here, let's get some screenshots. So the analogous concept is if the sun was the middle emanating outward, you'd see this is supposed to represent the stars. So the sun's crepuscular rays emanate outward from the source in a divergent pattern. But at the equatorial equator, you see this. You see something different, right? They don't actually continue to go out in infinity from the other side. They actually converge, right? So again, this model, this is what the sun, this is, on both models, not refuted. This is, as we said from the Weather Channel, this is what anticrepuscular rays are. Your perspective puts it in a convergence point. That's the analogous concept to the southern star rotation. If the observer is in the middle and the sun is over here, you would think, and the rays are emanating outward all the way out in perpetuity. But that's not what you actually see. What you actually see is it right over here. You see the anticrepuscular rays, as we started with, right? Let's see if I can get the video up. Probably not.
I'd agree with you as long.
Whoa.
Oh, that was Earth is Life. I'll shut up so they can speak.
Nah, I muted him. Sorry, man. We already did the Glover presentation. Right, so here's the same stuff. Same visual demonstration. And this is exactly the model that other people were trying to portray that was kind of lost on me when I was watching it, right? It's the same stuff we're looking at here. Same principle. Does anyone have any general questions, comments, digs?
How do the okay, so
Shane, I have questions.
When you're saying that the stars in the northern hemisphere, the northern part, they're being anti-crepuscular to the southern part.
No. What are you talking about?
That's what I was getting out of it.
What?
Yeah, because your correlation between the
I got a question.
Okay.
Why is Demon tried not
Shane,
to?
I have a question.
It's a joke, man. Finish your sentence, Demon. Come on.
Go ahead, man. Let me see where you're at. So what do you mean? What would you start to ask before I said what the fuck?
Well, it seemed as if you were saying that the stars in the north were anti-crepuscular to the southern hemisphere. So you're still essentially seeing the same stars. It's just and that would be the explanation to why you have a personal dome.
None of that makes sense. If I didn't know you, I'd say you were being intentionally disingenuous, dude. What the fuck?
I still don't understand how the personal dome follows you then.
It's just an azimuthal grid. It describes how you see around you, the limit of your vision. That's what it's describing.
Right.
And again,
so at that point is where they're becoming anti-crepuscular.
No.
No, the two don't go together.
Yeah, no, I'm not saying that the stars are anticrepuscular rays. I'm saying that the only concept to bring from the sun's anticrepuscular rays to the stars is the fact that your perception will convert those rays into a counter-convergence behind you called anticrepuscular. You're doing the same thing to the stars above you. Your perspective is warping them into a counter-convergence point we've renamed Sigma Octantis. Did Demon leave?
I probably need more visuals.
Yeah, as soon as you can grasp mind, I'm pretty sure it's gonna click.
Playing around with this model is what clicked for me. So if we start off with the guy right under Polaris, right, this is the easiest one, right? Because literally it's the little personal dome, which I hate that fucking phrase, right? I keep trying to call it an azimuthal grid of observability because, again, personal dome sounds stupid. Azimuthal grid is how everything like Solarium works, how it functions, how celestial navigation works with elevation angles, readings to a star, how literally timeanddate.com tells you elevation angles and sunrise angles. I mean, this thing, you know, it's pretty accurate. It's pretty silly to say that it doesn't work because of, you know, anticrepuscular. But in the middle, demon, right? Like, you see the stars circulating around you. This would be analogous to that first star trail we saw when the guy was in the north, right? It's kind of like, here, let's see. Let's go back to Solarium.
Okay.
I'll put him in the north. as far north as I can go there. So Polaris is directly above me. Let's turn off this grid. Let's make it. How come? Oh, I'm in 24-hour sunlight. Too far. Okay. So I'd say we're right here. Like, right here is what we're emulating on the left and the right. Right? So the equatorial grid's in blue, azimuthal grid in green. But azimuthal grid is what this is. It's how Stellarium functions. Look at the elevation angle is literally around you. Here, let's turn this off. Let's get to the dark. Literally the elevation angles around you. See 340, 350, 360? This is how the grid works. It's how celestial navigation works. It's how farmers' almanacs give you bearings of elevation angle to the observer. Right? If you know the time, you know where this star would be because they're so consistent. And this is how you would measure it. This is the angle you would get. This is how you'd verify your sextant readings. Is everyone cool? Questions then? I got nothing else. We're just kind of chilling here. That's the whole presentation on how I think it works.
I think the globes are spiraling right about now. But
I have questions, but I think they're going to be best answered by me opening Stellarium and looking at some stuff again myself.
Yeah, mine's off topic as well, so.
In my case, I'm not really understanding what you're getting at, so anything I say is not going to be very useful to you.
Understanding what I'm getting at.
Yeah, I thought I had it, and then it collapsed like a house of cards. Oh well.
I just don't see how it's like. I just don't see how it's important information in relationship to us. What's being discussed. That's all. It's interesting. Not saying, not trying to discredit it, but I'm just trying to piece it together.
It's not irrelevant to what's being discussed. What do you mean? What's being discussed? Like flat Earth?
I just think, like, looking at it at face value, that's what I'm seeing. Like, I'm sure it is important, and it's just listening to the conversation. It's just I just fail to see the importance. That's just me.
I think it was amazing.
Yeah, I thought it was really interesting.
Very interesting. I missed the first part of it a little bit, but so what we don't factor in, what they need to factor in, because is the speed that we're all flying at the same time, right? So we don't have to calculate speed because we know we're not flying through the air, but they have to calculate speed, right? Flying all over the place, going up to down, circling. I mean, that's what they think, right? They think that we're going around the sun, correct? But which direction, right? Are we going up and down over it and flying out there? Do you understand?
So 11 different vectors of movement, as well as the rim velocity on a globe, has the different rotation rates.
Yeah. I mean, that's just like, I don't understand how the guy thinks it's not relevant.
And with what Shane you're putting forth, it's really just two things rotating, or is it, or just counter rotation and
it's one thing rotating. Like, see how Walter Bislands' model has the stars above the Earth in this wonderful pattern? I think that's very similar to how it actually is, and I think that the little personal dome below it is really just representing the azimuthal grid, and that when you go to the equator, you see that you're so far from the center, you can't see the spot it rotates around. It makes perfect sense to me, right? If you're this far away, you can't see the center. If you're on the equator, like we started with the equatorial star trails, you see exactly this, right? Everything around you. But then if you go further, so literally Sigma Octantis only exists in the south while looking south, while facing south. That's the only way it exists, right? And so it's the counter convergence. It's literally your vision is seeing the stars on a grand scale of everything you can see, and because it's emanating out in front of you and behind you in the same way the sun's rays would, your perception is warping it into a convergence behind you. They're not actually converging there. There isn't actually a second rotation. There isn't actually a southern pole. It's just a product of human perspective on a grand scale. And again, the best analogous concept I can come up with is the sun doing the exact same thing to its crepuscular and anticrepuscular rays. In both models, you say that crepuscular rays are a product of human perspective. Your perspective is warping them in a sphere around you. So you see in a sphere of vision around you. So, I mean, I don't know.
Yeah, maybe if it's a glober who doesn't get it, maybe they don't get that. They assume that it's the sun rays, which there's no such thing as rays, but the sun is coming in parallel and appearing to converge and diverge due to perspective. Maybe they don't understand their own model. That's all.
What's interesting about what Blaze said, about going to these incredible speeds, 66,000, 450,000, 1.3 million. Physics has it that the reason we see elliptical orbits for the planets is because the math, the physics, doesn't allow for these planets to go around in a circular fashion. Physics, math, for their little cartoon or fairy tale to work, demands that the planets move in an elliptical orbit. So that's why we're told an elliptical orbit, because if we were told a circular, their physics, their math wouldn't work. It's all in the math. So if somebody says it's in the math that proves that we live on a ball, that is the most idiotic thing that anybody could ever say. And they're basically saying, I am God because my math works out. And it's just unbelievable, the farce that is the globe Earth.
So did I misspeak then, Shane? It's one actual rotation, and is it only two apparent rotations? And I mean, is this along the same line of thinking when a glober says something so silly as we observe star trails, or like stars don't actually trail, right? So is it one apparent motion?
It's one rotation.
Or one apparent?
Yeah, one rotation.
How many apparent rotations then?
As many as there are observers to see it. Isn't that crazy? Literally, the way this works is anyone in the south, further south of the equator, looking south, you see your own special counter convergence point, because that's from your perspective. Just how each crepuscular ray is personal to you from the sun. If you move to the left, it's a different crepuscular ray. If you have a partner to observe it with you, they see the sun in a different spot, right? It's the same concept as you put a flashlight on a blanket in the middle of a room and have a person stand in the left corner, the right corner, in the middle, and have them point to where they see the flashlight. They'll all point to a different spot.
Very true. And why is it so? I mean, you might not have the answer, but why is it so rare to view anti-crepuscular rays? I mean, what makes them so difficult to view?
I think it's probably the conditions, right? Because you have to be able to see to the furthest depths of your vision in each circumstance to see the end, right? Because you have to see, the sun has to be producing crepuscular rays, so conditions has to be right for that, and then they have to be clear enough to see it on the other side. I think the one we saw was in California.
I found my picture of it from inside the plane, and the anti-crepuscular rays are coming up from the ground towards the camera. They like spread outwards all around. It's really hard to see though. I was trying to get adjust the filter to make it more prevalent, but let me see if I can put it in chat.
Well,
you know what
super
you know what else was,
all of a sudden even stride. That's not just me, right?
Yeah, no, his mic is like down or whatever, but I can still hear him. You know what else is really supposedly rare to view, as well as the anti-crepuscular rays from the sun? The southern point of rotation is very difficult to view.
Like I keep saying, man, it's 12% of the population can see it. 12% lives in the geographical location necessary to observe a southern rotation, and anywhere in the south would see their own southern rotation personal to them. Like that's literally how it would have to be for this to work. The only the problem that I get a lot, the objection I hear a lot rather, is that that's not south, right? When you get the observer and you can put it over here and you see them looking south, they don't get that south is every direction away from the center. So I haven't heard that one yet, but that's cool.
Shane, can you hear me?
B-ball, yeah, man.
So what happens when we put a second observer on this map at the same time?
What do you mean? Are you gonna ask me if the dome's touched, dude?
If we have a second observer, like one in Australia and one in South Africa, and they're both looking south at the same time.
Kind of like this.
I think he means like at the same time on that little thing that you have, but
well, I mean,
think that works too.
so this is the Southern Cross observed at the same ETC across the same spot, and here's me using the wonderful Bislands model to show how each observer would see that at the correct indication and matching Stellarium's observation. So
if one person is in South Africa looking south and another person is in Australia looking south, they're both going to see the same star rotation flat Earth?
The same star rotation? Are you trying to conflate a specific observation, a specific elevation of a star? Because we just got finished explaining that counter rotation is a product of perspective to each person, right? So
no, the rotation of the stars, like if you do a star, like a time lapse, if two people do a time lapse at the same time, how are they both seeing the same rotation in their time lapse?
I don't understand what you think the same rotation means. As you can see, they would see a slightly different rotation. They would see different stars in a different pattern at different elevation angles crossing at different horizons.
No, like if you and I went out tonight, right? We both point our cameras south and we saw a rotation in the stars. But on flat Earth, we're looking in different directions. How does this model explain that?
South is every direction away from the center. As you can see, right, the fucking compass that I put here for each observer is looking south, and you can see each observer with the red line is actually from the observation point looking on their grid southwest to match the observation from Stellarium to see where you would see this one. This one should be a little bit more south. I fucked it up, but whatever. It's crude, but it matches the observations because I put them all on the side. You see, they're all over here. This is where you'd see this one. This is where you'd see the Southern Cross. This is where the observer would see it. Here's me mapping it out across the plane using the same principle to show you exactly what's depicted simultaneously. I mean, I don't know, man. What does everyone else think?
Yeah,
well,
but what you have
seems to
here,
think that it works out fine. Is what it seems
what
like.
you have here.
You asked the question, you got the answer. So would you say now, wow, it actually works just fine?
No. But what you have here is on your little blue map here. These are all you put all the same stars in different positions, right? So you have up here. You have. Well, I'm looking at what is that? 5 a.m. You have the Southern Cross there.
Earth.
Then at 11 p.m. you have the Southern Cross there, and then at 6 p.m. you have the Southern Cross there. So I don't understand how if the person in South America looked, I don't know, west, they would be able to see the Southern Cross over there as well, according to this map.
No, so again, here is exactly where you would see the Southern Cross, people. You see this? This is from Salvador. Here's the declination. Here's the reading. Here's where it appears at the grid. About what's it? 40 degrees, right? And then you go to the other observation point and you make the same connection here. Let's see all the way over there.
Shane, this is
all the way over here. You see it from this point, right? So this is Johannesburg. This is where they see it on their grid. Not south, not southwest, southwest. And that's what's represented in this little model right here.
Yeah, but Shane, you're showing Stellarium, which is on a globe model. That's why they all see it looking south.
No, they see it southwest, which, by the way, makes no sense on the globe model.
Let me open Stellarium. Hold on.
Can I ask one question just quickly?
Is it about bendy light, Jimbo? Sorry, I'm just kidding.
No, you're right. So for the person in Perth, right, in this screenshot that you're looking at right now, which way are they looking to see the Southern Cross?
Isn't it prefaced in the word southern?
Well, no. Well, he's got a picture that's modeling it. I want to see which way it is.
South.
But the line. So on that image, right? That red line. Which way is that line going?
Southwest. The line is meant to match the person's observation direction. Sorry, I'm going through the pictures.
So go back to back to that one, but behind at the back. So you've got
so
not
Perth.
this image.
So here's where you see it from Perth at that time. You see the bottom half sticking out of the horizon.
Yeah, but so go back to the other picture of the disc type Earth thing going.
You made an error in your artwork.
So where are they looking in that image? At 5 a.m. in Perth.
Yeah, so it's supposed to be like, so yeah, it's definitely not perfect, man, right? Like, I tried to match it best I could, but I did it in like a couple of minutes and I threw it together. That line should be, it totally works, dude. It totally works. If this line was a little bit over here, it would match the perfect declination that we just saw in the picture.
Right now, he's looking northeast, man.
No, he's looking southwest. You see how this? You see how this compass is here? You see how this compass is pointing north, and this is south, and this is southwest, dude?
Yeah, that's southwest, dude.
There's less than 90 degrees between the north line and the red line.
Are you confused?
But anyway, I said that was one of the major global objections, so I'm glad that we didn't get disappointed.
Do you think north is 90 degrees to south?
No, I'm saying that the observation line is above east.
So I think what he's getting at.
Stellarium says it's south. Anyway,
I think what Jimbo is. Oh, I'm sorry. I think what Jimbo is getting at is the fact that on the flat Earth, the lines of observation. So if like where they're looking to see the Southern Cross, they neither go parallel nor do they converge at a single point. I think that's what Jimbo's getting at.
That's a fair objection, but it's not necessary for you to see the same thing if you use the azimuthal grid, which powers stellarium and suncalc, right? It doesn't have to be at a convergence point. Matter of fact, it's kind of a misnomer to think that you would see the same, because as we just pointed out in stellarium, the same star from the same observer, again, we started by picking one, right? And we said, look, as you move, you can track it, and you can see, here, let's stop this. So like,
it's not quite what I'm saying. I'm saying that the person
see
different declination.
Hold on.
Yeah, and right ascension too.
So the person in Perth is seeing Southern Cross where? What direction?
Well, yeah, the declinations are all messed up. You're right.
Perth, southwest.
So on the
yeah, see, so I drew it more over here on my little design. I drew it more over here, but it should be over here. Yeah.
No, you didn't. Go back. Yeah. It's pretty much south, right? So the red line should be almost parallel to the blue line if it's near south, and it's not even close to that.
Your objection is noted, dude.
It doesn't work, man. It's not matching.
All right.
Why should it be parallel to the blue line?
Because it's south.
And the blue line represents?
North.
So north.
Whoops. Yeah.
But it's not a direct southern heading.
But the red line isn't even close to parallel. It's like it's nowhere near.
Well, if you're looking
like it's a little bit off. It's completely the wrong direction.
If you're looking southwest, you won't be parallel with north. Be like 45 degrees of it. That line, north and south line.
It's more like 130 degrees off.
Yeah, I'm gonna have to chime in and say I'm with the Glober on this one. Pac-Man Earth doesn't have these issues. Works just the same with.
This is not an issue. I just didn't draw it perfectly well, dude. That's all it is.
It's not perfectly well. It's not a little bit off. It is way off.
No, it's not.
I'm sorry. It is. It is way off, man.
Wait, are you talking about how like the red lines are not directly like going opposite of the blue ones?
I'm talking about how the red lines don't match what the directions in Stellarium.
Here, let's just look at this, because this is the whole concept. See how from this observer point, let's say it's this star over here, that's where he sees it at the perfect declination. Here it is. I'll move it forward. That's where it is. Same time, same declination, southwest, just over there. That's where he sees it. You following? So I didn't illustrate it exactly correctly.
But this breaks down when you put two observers on the same map.
No, it doesn't. That's silly. So here's the Perth observation, right, all the way over there at that declination. Let's say it's this star. Wrapping it around, he sees the same star up here at the same different declination, depending on the observer, and then it wraps around.
But Shane, there's got to be reason it doesn't work because globe.
Because globe. Because
no, it's because you can look at it and see that it doesn't work. I mean, as soon as you put two observers on there, let's say one observer looks to the right or to the left a little bit. Are they going to see another rotation?
I don't know, man. Does any flat earthers have any questions? I already did this to the
Yeah,
globers,
I was just going to add something, Shane. So, sorry, mate. Hey, I just posted the north-south magnetic declination in Australia in the general. So when you with those maps that you're showing, when it shows south, it's actually not south. It's magnetic. So they need to adjust. The globers need to adjust to get that direct north to get the south. So when they're using a compass, it's off.
Compass
so he's looking at that map, that flat map, and doing a direction from Perth, and it's off.
Yep.
Yeah, the compass.
That's how you correct it.
Magnetic north has nothing to do with true north.
What are you talking about, mate? How do you get true north? How do you get true north?
True north is the actual axial rotation point in the sky.
Where is that?
True north.
Where is that? Where's the axial rotation point?
Directly over the North Pole, 90 degrees. The magnetic north is not in the same place. We know that.
Yeah. So how do you get true north in the south?
You
can only go off a compass.
90 degrees when you're in the center of Australia. Oh, I'm not sure. Yeah.
You can only go off a compass, mate.
You look directly north, 90 degrees.
What's directly north? Off a compass.
I'm sorry, directly up 90 degrees from us.
How do you do that?
That's not how you.
Do you not know how?
This is not how you find true north or true south.
If you follow a latitude directly south.
That's not how you find true north,
man.
True south.
Yes, that is how you find true. When you look at a map, it has three different types of north.
How do you know that map's
true north,
correct?
Grid north, and magnetic north. There's three different ones.
You can only do magnetic north in the south. You can't do true north.
So when you follow
show me how you get a point north of true north in the south.
Follow a longitude line, that's directly south. That's how you find true south.
How?
No.
Follow a longitude line directly south.
I'm surprised you don't know how to find true south or true north because it's
you follow.
Please don't interrupt me because I'm getting a little tired.
You just asked me a question.
I didn't ask you a question. I said I'm surprised you don't know how to properly do it because it's one of the better.
I do know how to properly do it. I'm explaining it.
Dude, interrupt me again. I dare you. It's one of the better globe proofs, and it's not what you're saying right now.
Well, listen, I mean, not to hate on my globe buddies here, but I did already do the globe side of this, so I'm trying to get flat earthers' opinions. If you guys have any questions or comments,
sorry, man.
Hammer.
I was just adding
it's all right, dude.
Just for magnetic declination. That was it. That's all I had to add. Thanks, mate.
Dude, I appreciate you, Jimbo. You gave me all the objections that everyone in Gem Pandas did, like a religious, like in the same order with the same ump. It's cool.
I got a question as a flat earther. What happens when we add the wandering stars to this? Does it get really crazy?
What do you mean to this? Why? Why would it be any different?
Well, because they're doing different patterns, right? They're not doing the same thing. They're not just going straight or in a circle or whatever.
Here's the directional proof for the people who were struggling before.
Or, okay, how about the sun and the moon? I don't know. What are they? The sun and the moon work the same way?
What? Sorry. The sun and the moon work the same way as what?
As what we're seeing with the example with the stars.
So, I mean, I do think that the azimuthal grid is used for sun calc and trying to find the sunrise and set declinations. That's true, right? I got a couple of gifts to show that.
So I'm still looking the anticrepuscular patterns. I'm still like trying to wrap my head around that. So octans presents itself as 3 stars revolving around a point.
I want to know, Shane, while he's thinking this really slowly.
I can see how that would be like a maybe like a reflection or a similar or to the same phenomena that we see in the north.
Well, no. See, I think it's just so the one in the north is different than the one in the south. The one in the north has a true focal point, a true rotation. Everyone in the north, the 88% of us that live here and see that, are observing the true north rotation. Only the 12% of us who deep south of the equator looking south see the perspective created counter rotation that we have misnomered the Sigma Octantis, right? And they think it's a star. It's not.
So the star that they see, that light point in the sky, that's what, a reflection?
What?
I guess I'm not following. So
What? So first of all, have you seen a picture of Sigma Octantis? Has anyone?
Yeah, you can't see it.
Not the point. The point that the constellations supposedly, well, that they seem to map around. This is definitely not like a single star there.
No, it's not a single star, but it's not always.
There's a cluster of stars that you can't see with the naked eye.
Yeah, that's why it's called the crux.
Yeah.
Yeah. Not just the Southern Star.
So is this
Yeah,
model,
so
this modeling assuming that the light is traveling in a straight line as well? That light is only traveling in straight lines?
I don't think light travels at all, dude, right? I think that it's already there and you're only quantifying the rate of illumination, and that light speed is just the quantification of the rate of illumination at 186,000 miles per. Like, it's a little bit crazy. I don't want to get into pathways of light, but I do think that super bendy light is stupid. So here's what they would say is the Sigma Octantis, right? Like, so literally you can't see it with the naked eye. You can't see it. I'm saying that wherever you are in the south, these vary, right? Like, see how it just dipped? I moved a little bit more south. Crap.
Yeah, and the Southern Cross is supposed to be made up of 5 stars.
But Timbo from down south says he's never seen it. Have you seen it, dude?
Well, that's why nobody ever wrote stories about navigating from it, bro.
Yeah, you can only see the Southern Cross, but you can't see the what they call Sigma Octantis.
Right. And I think that works, right? Because
Southern Cross you can see all the time. Except for in the day, obviously. But...
Timbo and Jimbo, and they're both Aussies. Sorry, man. I did not mean to jump in.
No, you're all right. I'm Timbo. Timbo.
Oh, sorry, dude. Yeah, I should have specified.
That's Limbo. I'm Limbo. But let me see.
So this is what they're saying exists, and I'm saying that this isn't really there. I'm saying that this little thing is exactly analogous to this little point over here that travels with the observer, right? So literally moves the same way, is observed the same way. Makes total sense to me, but I could tell I'm probably losing the Globers.
That would be Earth's life's question, constant question that it doesn't work when there's 2 observers. You're showing it right now. 1 observer, 2 observer. I don't know why you kept asking that over and over as you rolled this little thing around in a circle. It's crazy that he kept saying that. That's nuts.
I know you don't like that word, Shane, but yeah, maybe he's getting confused on the personal dome.
Yeah.
Missing out on the word personal.
Well, I keep saying it because in the Gem Panda snake pit, like the question that they couldn't get their heads around, he was like, so if there's 2 observers and my dome, is my dome touching your dome? Is it overlap? I'm like, dude, that's the dumbest thing I've ever. And it's probably a little bit gay. I can't even explain to you how dumb that question is.
Oh, if our domes touch, we gotta fight to the death, bro.
Right.
Don't be putting your nasty ass dome on my dome. I don't know what you've been observing.
I swear, like
I've never actually been in Gem's server. I've never been once. I heard it was so toxic. I was just like, that's not for me.
it's it's a good place to like bounce ideas off of, right? Like, literally, this is
I
how.
was going to say, Andy, if you haven't been in there, you've got to experience it at least a couple of times, mate.
Really? I don't know if I subject myself to that.
You can just go in and listen. They'll fight amongst each other.
Listen, though, I gotta say it because you gotta speak for good people wherever they are. But there's good people in there. There's some good people in there, but it is pretty shitty. But it's no different than 24/7. There's good people there. Every group's got a dickhead in it, but I would say every group has an angel in it too.
Right, so I was applying the same thing to the sun, right? Here's the I forgot I set up the other tab for it perfectly. Right, so as the sun freaking rises and sets, literally it becomes visible. And if you look over here, it gives you the azimuth to your goddamn elevation angle, 18.5, so you can match it up exactly. Right, so here's where it appears. Here's how it rises, right? Southeast, all the way over here at its zenith, and then setting as it really it goes further away, right? Makes perfect sense. It's how everything works to me.
How's that light traveling? No, I'm just kidding. So did you give up on so you're saying it's one in a rotation or whatnot, and it's crepuscular, anticrepuscular points. Have you given up on matching the constellations?
No, so that's a whole new thing, right? Like, so it's possible that the southern stars are like parabolically mirrored northern stars, and if you match up like some of the constellations will line up weird like that. It's a whole other thing I haven't really finalized yet, but the resemblance is uncanny. It's almost as if you take the southern sky and you warp it a little bit and elongate it towards the right diagonal, and then you match it up with the north, and it's a near perfect match. There's a couple of constellations that rise. All the galaxy clusters seem to match and correspond that way. It's kind of weird. But there's been a lot of people.
That's where I think I'm trying to get ahead of you a little bit, because
I tried to separate that from this presentation because a lot of people confuse those things. Like Demon Star was like, so the parabolically reflected anti-crepuscular rays. I was like, no, none of that.
Alchemy, I should say.
Yeah, I mean it is crazy. I have a video of it somewhere.
Mother of God, please clean your desktop. That is awful.
Don't you worry.
Add more tab.
The only thing I could add is the sun seems powerful enough to have these rays, crepuscular, anticrepuscular, because it's just so bright and travels so far. The stars, I mean, we do see them and navigate by them at great distances, maybe even further, for sure than the sun, right? In that way, but it doesn't give off the same light. So it is I guess tough to see why it would. What?
So the counter rotation, it's got nothing to do with the light, right? It's got nothing to do with the sun. It's just your perspective on a grand scale puts apparently crepuscular rays into a counter convergence behind you because it necessitates by you seeing in a sphere. You see in a sphere around you, more accurately a hemisphere, right? Like, it's just the way it works, and that's why it cuts off. That's how the horizon works. It's how sunrise works. Here's a earlier representation of someone demonstrating the same concept, but kind of poorly. I remember watching this and going, I don't quite get what you're driving at. But if you think Walter Bislands' model, and that little thing is just the stars without the actual dome, that's crazy. And here's someone taking stellarium from the north, mirroring it from the south, and showing you the same fucking constellation. This is totally not part of my thing, but I do think it's interesting, man. Could be something there.
Yeah, so page 1 in our presentation 1 is just it's simply perspective apparent motion. When we see these stars go in a straight line so far out of view, but we see in this grid, even though we know it's going east to west, it can, due to our vision in that grid that you're describing, appear to be going the other way, going, right at the end of its journey at its furthest point.
I think someone did the Big Dipper too. Right? Like, yeah. I mean, I don't know. I probably shouldn't get into it.
No, you did great on this one. Yeah, for sure. Yeah, I mean, just that you brought these questions to the minds of those who would do anything to deny it. Not that they're making up lies at the moment, but just that you bring these questions and this doubt to them, it shows you did a good job. Yeah.
Thanks, man. I mean, I do think that the sky is how a big part of the deception, because it does lend itself to a south celestial pole if you didn't know what you were looking at, and they kind of use that against mankind, I think. So it is important to understand what you're seeing in the sky and how it makes perfect sense on your flat reality without having to invoke ridiculous Masonic spaceballs.
Yeah, I mean, I was A-okay with. I mean, I had seen these videos that you're showing a pretty long time ago, but I was A-okay with Eric Dubé's showing with the personal dome, and how it goes out. And due to perspective, it seems to, be going the other way. I was good with that visual, and then watching it being demonstrated again and again. Yeah.
Yeah, I didn't get it when I watched his stuff though. Or like, I thought I did. Or like, I felt like, yeah, I'm missing something. Like, it's like shit. I mean, I got that in the end. I mean, maybe it's different for everyone, man. It's a different catalyst that makes you get it.
Well, I mean, like your point stands that it's only due to a time lapse that we see this. It's really only on a time lapse that we see
true.
this happen. It's not in real time, but you can when you do a 180 and turn around, see it going clockwise, right? But you did a 180. But we only see it in with star trails that we know are just an apparent, not actual. They're not really trailing. It's just a perspective on the camera.
Time lapse. Yeah, you can never see him with the naked eye. That's a good point. You'll never see him, right? Like unless you do a time lapse with a camera.
So Shane, do you understand why we reject this model?
No, I think that someone said bendy light impossible, and you've parroted it every time that anyone brings it up.
Well, light only bends. So I've heard people say through a different when it changes mediums. Mm-hmm.
Right. But when you try and use this model to explain southern star trails, it creates more and more questions about sunlight, the moon, moving into the moon, stars. Like it just makes more and more questions.
It really doesn't, man.
Even if it does, what's wrong with more questions?
So
I mean,
okay. So you're suggesting that the sun is rotating above the flat Earth like that, right?
Everyone is, yeah.
Okay. So when we look at this and we see the sun rotating above, what's stopping someone on the other side of the Earth from seeing it?
Really, dude? How do you ask Flat Earth 101 questions, dude?
That's the whole reason why we ask those questions. I mean, it should be obvious.
No.
How long you been doing this for? There's no way you're not being disingenuous right now.
No, I'm really asking a question.
I would just say like atmosphere, i.e., a more denser and denser medium is one reason. Like the thing that bends light, that like dense medium.
And how is it that the sun is going one direction, but it's going in along a farther direction? Like it's traveling in one direction shorter than it's traveling in another direction.
Can you be specific?
That makes sense. So when you look at Shane's model, there's an oval of light, right? The sun is casting an oval of light. Is it really casting an oval of light in reality?
I don't know where's this model, the oval light?
No one knows what he's talking about here. Let's do this.
Put your model back up.
Time and date?
No, not that one.
Oh yeah, this one. Here's how it makes perfect sense on every model.
Right. Okay. So the bottom left. How does the sun only illuminating that portion of the Earth?
How is it not, dude? It's right now. It's raising and lowering in elevation and wrapping around as it's supposed to. It matches time and date perfectly. It does the equinox and both solstices, dude. Like,
Now there's a circle of darkness. You see that? There's a circle of darkness. What's creating that circle of darkness?
the absence of light.
Yeah, but do we ever see something like? Can we recreate that?
How about this one
on a small scale?
Does this one help you out at all?
This one I saw.
Will that work on a small scale?
Right there, I saw this video on Flat Earth 101. It was actually called Flat Earth 101.
What you just asked is, does shadows work on a small scale? That's what you asked.
No. Look at the model, right? How is it? Okay.
It's a shadow.
The one on screen that he's literally showing you on a small scale, like you asked.
Join the live stream,
this one has. So this one, right? The sun is on the outside of the dome.
Oh, is he not watching the lives? I thought he was watching.
Yeah, I'm watching.
Yeah, well, you're referencing it like you're saying, look at that video, so it makes me think you're watching it.
So the light is on the outside of. Is that what we see? The light is on the outside of the dome.
I can hear you. You're just spiraling, dude. Yeah,
I'm asking about what you're showing.
The pattern of light is able to be repeated on a small scale.
See, it's exactly.
We can all
this is
accept
perfect,
that, right?
This is it works on every model, right? So I don't know why we're arguing about the sun.
Okay, what you're showing, right, with the light on the outside of the little dome thing, that's suggesting that the light is on the outside of the dome.
Yes.
No, that's not suggesting anything about reality. All it's a demonstration of is that the pattern of light is repeatable on a small scale.
I would say
through this demonstration,
like as the global argument, your refutation should be so there's a dome, right? Because this actually requires a dome to function. I don't know why you're not going there.
That would be
like I'm giving it to you on a platter. You still try to fight the hard one. Like that's the easy refutation. And I would just say, yeah, it does require a dome. But this is an example of how light with a dome it matches exactly timeanddate.com for the integral parts of solstice and equinox. So
well, that's kind of like when they didn't mention a gyro compass for true north, right?
So again, you're showing an example of the light coming from outside the dome.
Yeah,
because that's all we can do as human beings is show you an example on a table. Like we can't get outside or inside of any dome if there is a dome, but we can. When you ask and say, "Hey, can you show me an example on a very small scale?"
There's a much bigger problem with this.
With the tools that humans are given and where they stand, and above a table with the tools we're given. This is what we can do. I mean, do you have a problem with us being human? I mean, what's the?
No, it's just that this doesn't match reality. It might match what you're saying.
Exactly.
But we know that the light is not coming from outside the dome, right?
No, you don't know that. I personally think that the source of the sun is outside the dome, and we see the reflected personal reflection of whatever personal reflection that we see. I think that's what's in here.
I have a question.
We see. What's up, Bacon?
Is that really the big deal? Like, is that the crux of the disagreement here?
Yeah, you should be able to
flat earther now.
Look at this and be like,
we got very far sidetracked.
But you should be able to look at this and be like, okay, is light coming from inside or outside the dome? You should be questioning that. It shouldn't be like, oh well, it looks like that, so therefore that should be.
See, I'm not questioning it because it fits perfectly in my mental model of how things work. You say, is it inside or outside? And to me, it's always been outside, right? Even from the Go Fast rocket, when it goes 72.3 miles up, and you see the sun straightly over what's right over New Zealand from Arizona desert straight through the bottom of the ball. Literally, you can tell, like. You can see it's above the firmament. So
now let's put a camera on the other side in that darkness
you
portion.
You can also see it below a plane at 32,000 feet. So the optic sun, it appears at different elevations based on the observer. So
can I?
Okay, now let's hold on. Let me just ask one more question, real quick.
Next, naysayer. Next.
Let me just ask one more question, please. So we have the light on the outside of the dome, right? Now, if we put a camera on the other side in the darkness, would that person not be able to see the light?
Huh. I don't know.
Yeah, that's a really interesting question.
Yeah, I think
wouldn't it stand to reason we wouldn't know until we tried it?
Well, yeah, that is
Can
the
I-
fact of the matter, that there's only one way to figure these things out, and that's through experimentation. So let's do it, guys. You know, but who has the ability to put this to
Who
the
can make
test?
who can make a
Blender.
camera that
We
small?
can do that on Blender. Blender,
Make a camera that
you're able
small?
to simulate glass.
Well,
on Blender.
you understand how much we can take Blender for granted when it comes to applying software simulation to the real world. It has its limitations, of course. We all
Whenever
understand
possible, I
Yeah,
would
but
rather
one
do
second.
the demonstration in reality and not in the simulation.
Of
whenever
course.
possible.
Yeah. Simply
Sure.
put, yeah.
Can I?
You're completely
Get
correct.
to it in the one sentence, please.
Sure. Listen.
Go
yeah,
for
sure.
it. Was that bacon? Go for it, man.
Listen, dude. I'm gonna say it. That's annoying when other people are talking and you're like, "Can I say something? Can I say something?" But somebody else is already talking.
Yeah,
Are
whatever.
you a
We all.
child?
Well, but I
We
was
all.
trying to jump.
Hey, we all do
I'm
it,
sorry,
man.
but I was trying to jump in for a while. Like
No, we
before you
don't
guys were
all
talking.
ask. Can we
Someone
talk in the
let
middle of your
Bacon
fucking
speak.
Go ahead, Bacon, please.
All right,
I want to hear what Bacon has to say.
Yeah,
Right
there's
now,
a
I get it
couple
on
of
my
things.
teeth. Oh.
Right.
Yeah.
This model seems to account for the shape of the terminal line, so where it separates between day and light. There's a couple more.
Could you repeat and more
Sure.
clearly, please?
Is my mic bad?
No, just it was
It is a little
just
musky.
it was just kind of
English
rushed.
is.
My what?
It's not the mic. It's English.
Okay.
Go ahead.
I can hear you fine.
A
Just
lot
go ahead,
better
Bacon.
than that. All right. So there's this model seems to match the shape of the terminator line. So the line that separates light, day and night. That
True.
seems to be similar to what we observe. There's a couple other things that would be interesting to see if that model can account for. One of them would be like what Bebo said. If you can see the sun from those dark places. Another thing I would say is if the sun can still look like a circle during the whole day, if there are no distortions.
Is that an oxymoron though?
There are
To
no what?
see
Distortions?
the source of light from a area that is consumed by darkness.
Yeah, to see
Isn't that
light
kind of an
in
oxymoron?
the absence of
It's
light.
almost like
Yeah, I don't think you'd see the sun from the dark part. I think it makes sense what you're saying, but I mean, given that where you can see the sun, I think it would be nice to check if not only you can see the sun without distortions, like it looks like a circle the whole day, but also if the sun is above its ground position, because its ground position is where we see directly overhead. It would be interesting to see if in that model you would still have the sun in above the correct ground position. That's all.
Yeah, it wouldn't be not interesting. Yeah, and it wouldn't be certain, like whatever results come out of it, and it would be interesting.
Well, I mean,
in a real simplified, like rudimentary sense, the places we would assume you can see the sun are the places illuminated by the sun's light. So if you're in the darkness, I don't really expect you to be able to see the sun. I mean, I think that's fair.
I have a question. I have a thought about this. I've been thinking.
Can't always see the sun when you're in the light.
Look, okay.
Dawn, dusk.
Let me just ask this, and someone correct me if I'm being fucking retarded on this, okay?
Sure.
You're being fucking
retarded. The example, yeah, thank you. The example I've been thinking about for this is you can stand somewhere where a street light isn't illuminating it. You can still see the street light.
What do you mean? Isn't the street? Well, hold on. If you can see a street light, is the street light not shining upon your face?
No, the light will be reaching you, but you won't be illuminated.
No, that's not his point.
It's so far away.
Okay, go ahead.
Yeah,
I don't get it.
Hold on.
Go ahead.
Now go 10 miles away from the street
miles
light
away
and
from a
tell me if
city
you
and
still
see the
see
city
it.
lights.
Yeah, but I'm thinking scale here. The sun is obviously bigger than the street light, right?
So you're saying
Yeah,
that
we're
you
talking
don't,
like a lighthouse.
you guys still don't understand
What's the nuance?
why nighttime doesn't debunk flat Earth? You guys think flat Earthers have never
No,
seen
they
nighttime?
don't.
Good God, guys.
They're one.
Anyway, that's it for my person. Did you guys anymore have like questions on the stars? You want to end it up? It's been a good 2 hours, dude. I got through it in about half the time I did over at Gems, so that was pretty fun.
Nice presentation.
Well, I want to talk about that snow globe and the light source thing that you used to show that it'd work on both.
You're just asking for it, Shane, leaving it up on the screen.
I didn't see no snow. Did you see snow? I didn't see no snow.
You would have to add snow just to simulate an atmosphere, though. That might be clever. There's no atmosphere in that dome there.
So on that dome model, for the light to look like it was from what our model says, or what timeanddate.com says, it had to be held right down by the base, which on that model, by the looks of it, would be what, the southern pole or Antarctica? But that's not where the sun is all the time. Like when it was held above, like it'd be closer to the north or on the equator, it illuminated the entire dome.
I don't think he was paying attention.
No, here's a wonderful meme of it showing, the sun changing and lowering in elevation, according to the seasons, right? So, like, when you're saying, how come you can't see it when it's at the other side of the Earth? That seems silly. How come you can't see the moon all the time?
Is that the video of the globe, of the dome, sorry, that someone held like a little light source to? Like a tiny little pin torch?
No, it's a different meme.
Or is that's something different?
Yeah.
No, I think that's what he wanted to talk about. Was a little the dome with the light.
Yeah.
Are you guys bummed that it
When-
matches
when-
timeanddate.com perfectly and you gotta find something to gripe about because it makes too much sense?
Well, no, it
looks
doesn't,
like it.
because it had to be held right down by the base in order to have part of it shadowed. And we don't see that in real life. Like the equator on both models for you guys would be like in the middle of your dome. There's a line that goes all the way around for like a flat, whatever map you guys want. And the far edge would be Antarctica, right? That's why you can't get to the ice wall or the firmament or whatever. So in order to have it partially darken half of that dome, it had to be held right by the base, which, we don't see in reality.
Yeah, well, it doesn't cut it totally in half. Day and night distribution of sunlight doesn't go like that. It's not cut right in half of a circle. Have you ever looked
I
at
don't think
any
that addresses what I
azimuthal?
just said.
Have you ever looked? It does. You're acting like day and night are supposed to be a perfect line straight to the middle.
Well,
no, I never said that, Michael. That's you strawmanning me so that you can attack that rather than what I actually said.
Well, whatever. Thanks everyone for showing up to this and letting me do it. I appreciate it. It's good fun. Thanks for all the participation, including my good Glover friends. Appreciate y'all.
Could you name the good Glover friends, like by name?
No,
Just so we know that we don't-
Demon Stride.
That can't be done.
Thank you.
That can't be done.
Thank you.
Thanks,
Yeah,
Dave.
Well, you don't know if it's part of the show. Welcome to the show. If you don't know, it's part of the show. Didn't they teach you to reach for the stars while opening up the bars and keeping you chained down with mortgage bills and cars? Vaccines for your arms, kids sounding like supercharged, caffeinated hate-filled scars and rage-quit repertoires. No answers for yards, caught up in emotion that's not even yours. Imposter truths like impeccable retards, lined up for your serving of gish galloping wars. No remedy can save the lost, in love with the yarn. I'm tired of walking into refracted shards, poor science displayed by disgusting bards. Soaked in sin with your dupe is delight and a new hand of cards. Been so long, seems like for love I'm just too hard, I'm just too hard, that's it. Welcome to the show, where you don't know if it's part of the show. Welcome to the show. If you don't know, you don't know. Intoxicated 8 makes you believe you're spinning in space, why you have no shame or grace. It's a disdainful state I used to contemplate, how to save myself from my own self-hate. Wonder why I was even made with a dreadful fate, forced to try and awake with a full plate, no one to help me stay awake or educate. I've had to liberate and fight through hidden gates, but my brother, heaven could never be late, and rockets don't work in space. It's all fake, the show is on Mars, it's a joke, but you're too far gone, it won't be long. Fepe's beak is strong. We have our song and we march along like streams of knowledge leading to God's holy pond, and lives of truth that hits the bong and sings the song, turns mankind from the wrong. We come in peace with a holy gown and all of us wearing our holy crowns. So the earth is flat and we probably just won't get along. Just to go along, I said, welcome to the show, where you don't know if it's part of the show. Welcome to the show. If you don't know, you don't know.